Hello, my name is Francis Nedvedek. I'm a principal technology analyst with AutoSens. Today, you are listening to AutoSens Insights, and we have as our guest, Andreas Himmler, who is product manager, a senior product manager at dSPACE. Welcome, Andreas.
Welcome.
Andreas, your company does a lot of things, and today we're going to focus more on radar applications. Can you say something about simulation and validation in the product ecosystem in which you deal?
So overall, dSPACE covers everything that is required to validate and simulate for the development of automotive functionality, so for control units. dSPACE builds hardware-in-the-loop simulators, which are real-time systems. dSPACE builds rapid control prototyping systems, which are systems that you put into your car when you want to develop a new functionality. And dSPACE also moved into software-in-the-loop simulation because our customers want to do testing earlier, before they have their real hardware available. And part of the product offering from dSPACE is radar target simulation or simulation for the test of radar systems. We do this software-based. With this, the radar front end is simulated, the radar front end that is to be tested. And the main focus today is radar over-the-air testing. And this means that the real radar is available and a radar target simulator is put in front of the radar that is to be tested. And this radar target simulator simulates a target seen by the radar under test. Means the target simulator simulates an object with a given speed, distance, and radar cross-section.
So then what are some of the issues in getting this right? It seems to be simple on one hand, and yet when you look at what maybe could be encountered in the real world, it could be very difficult and an arduous task.
Yeah, it is demanding from a certain perspective because you work with radio frequencies. You work in the 77 gigahertz domain. This is one part, and on the other hand, you want to do the customers need a very precise simulation. So if they test a functionality and the user says, I want to the radar needs to see a target in 10 meters and 10 centimeters, the simulator needs to simulate a target in 10 meters and 10 centimeters. And the same holds for the other parameters that build up the simulation. This is what the radar needs to see. In addition to this, it is very important that there are no signals generated by the simulator that are unwanted. Otherwise, the radar under test would see something that is not really there, and that would ruin the simulation and the test.
So when you're speaking with a client and you're talking about applications, application requirements, you discuss different things depending on the customer and the application, whether the refresh rate is so fast or whether the smallest pixel sizes, whatever, or how many echoes are possibly coming into the picture, etc.
Right. We discuss the step size, how an object that is to be generated by the simulation system, how smooth it can be stepped through the range, through the distance. Can it be simulated in 10 centimeter step sizes, for instance? This is part of the customer requirements or radio frequency demands that the customer has. They often talk about spurious free dynamic range. That means it is not allowed that there are any unwanted frequency peaks outside of the echo that the simulator generates outside of what he should simulate. It's very important to have a clean and pure signal coming back from the target simulator.
So just for example, an oncoming truck or car or vehicle with its own radar, it's projecting a radar beam in your direction oncoming. What does the simulator do there? Does it ignore that, or the system should be built to ignore it and then it simulates an ignored signal? Or can you simulate different levels of transgression where some of this beam comes in and you can look at the effects on the whole system?
So the simulation setup, the first step is you have your radar under test that may be mounted in the truck that you referred to, and you put the target simulator in front of this radar under test. Then to test the functionalities that run into this radar in the truck are tested by generating different simulations with the radar test system. You can do this by having static objects, and you can also run scenarios if you have a closed loop simulation. This is a one-to-one setup, radar under test and radar target simulation.
Okay, I understand.
Of course, you can add additional radars to this setup, and customers have done this because they want to do interference tests. Does one of these radars interfere with another one? And then you have your radar under test, the target simulator simulates a target, and the test scenario is, does the radar under test, is that confused by the other radars that are also emitting waves close to the radar under test?
Excellent. Okay, good explanation. I understand now. What kind of range? We're sort of centered on automotive and vehicles, but of course you can simulate radar systems used for a very wide variety of applications, not only vehicles. Can you give us a general idea of what some of these other applications could be?
The applications we look currently at are mainly automotive applications. There is a simple reason for this. The automotive industry uses certain radar bands. Let's say the 77 gigahertz band, 24 gigahertz band, or 60 gigahertz band in the future. We cover with our systems these radar bands. And we can easily switch between different radar bands by just exchanging a part of the test system. If we look at other industries, they may use different radar bands, so different frequency. We currently focus on the automotive industry because the demand is so high in the automotive industry.
Of course.
We could also go to other industries, but we do not do it currently.
Okay, fair enough, good. And then at the end of the day, for those looking at a system level, the type of things that would be of interest, maybe what this radar would in the end be used for is detecting oncoming a target or a reflection, a vehicle, stationary vehicles, things at the side, presence of objects, as I understand it.
Right, yeah.
Okay. Good. And you have this DARTS system, DARTS radar target simulation. Can you say something about the DARTS? It seems like is that a new development, or is it something you've been working on for a while?
The DARTS technology, so dSPACE automotive radar test system, is based on IP that dSPACE bought from partners beginning of 2019. And these partners have been in this industry, in this business since a long, long time. So there is a long experience from our partners, and we still work with these partners that we can rely on. And our business is based on this experience from the past, and from this existing experience starting from 2019, we moved forward and gained more experience, built new systems, and we have now also new people on board that continue to develop the DARTS technology.
But how does that differ from other systems? What's unique about the DARTS?
unique for the darts is that it's a purposely built system for target simulation. There are other systems out there that are not purposely built for target simulation. But then if you have, let's say you have a modular system, you need to do some compromise because you need to put cards or boxes together. And this also, we are all engineers, so that means you need to do some compromise. The other unique things with darts is the precision that these systems have when it comes to target simulation. This is one part. On the other part, they are extremely easy to operate because we look at the automotive industry, at the test engineers. They want to have reliable and precise systems, but they also want to have something that is easy to operate because they are focused to be productive. And this is what we need to take care of.
Very good. Excellent. Thank you. Thank you for that. Well, then, thank you very much, Andreas. You are watching AutoSens Insights. We have been listening to Andreas Himmler, Senior Product Manager at dSPACE. If you want to see this video and others quite like it, then look for us on our YouTube channel or search for us in the internet. Thank you very much.